today's lesson recap. 9.1. I can use a mole ratio to determine the amount of any reactant or product when given the mole amount of any reactant or product. This involves the study of stoichiometry. Stoichiometry is derived from two Greek words meaning element, measure. It's the measurable relationships of the reactants and the products in a chemical reaction. It's basically the math of chemical reactions. Coefficients in a reaction tell you how many moles of each substance is used or produced. For instance, this balanced equation, balanced with 4, 3, and 2, tell us that 4 moles of aluminum react with 3 moles of oxygen to produce 2 moles of aluminum oxide. This is basically a recipe. Therefore, if I had 4 moles of aluminum, I would need 3 moles of oxygen to react with that aluminum in order to use it all up. If I had 8 moles of aluminum, then I would need 6 moles of oxygen. If I had 12 moles of aluminum, then I would need 9 moles of oxygen. It's always the same ratio, a 3 to 4 ratio. So we'll use these coefficients as mole ratios to calculate the amounts of any of the substances. If you only know the amount of one substance in a chemical reaction, you can calculate the amounts of all others in the reaction. For example, this is a mole-to-mole problem. You know it's a mole-to-mole problem because you're given moles and you're asked to find moles. So that's mole-to-mole. Given the reaction, 2H2 plus 1O2 yields 2H2O. The problem is if 23.97 moles of H2 react, how many moles of O2 are needed? We will set up our problem. Always write down your given first. 23.97 moles of H2. Now I want to set this up as a mole ratio, moles of asked for over moles of given. Our given is hydrogen, and they ask us to find moles of O2. So we'll put what we're looking for on top, moles of oxygen, and we'll put what we are given on bottom, which is moles of hydrogen. Now, I get the numbers that go in front of this from the coefficients. Oxygen in the equation does not have a coefficient, so 1 is understood there. So 1 mole of oxygen reacts for every 2 moles of hydrogen. So it reacts in a 1 to 2 ratio. I knew to put hydrogen on bottom because hydrogen is given. So I can go ahead and cancel my units. Multiply 23.97 times 1 divided by 2. And we will get roughly 12. We'll say 11.9 moles of O2. So if I had 23.97 moles of hydrogen, I would need 11.9 moles of oxygen to react with that in order to use up all of the hydrogen. I'll do another example. Given the reaction listed above, if we have 7.42 moles of O2, I like to write above each one so I kind of don't get lost. So I'll write my given here, 7.42 moles of O2. And it says how many moles of C2H2 are needed. So I'm looking for this, X moles. I do that just so I'll know where I'm starting and where I'm trying to go. So, first step is always to write down your given. Moles of O2. Now I need to do a mole ratio between what's asked for, which is moles C2H2. That will go on top. And moles of oxygen will go on bottom so that it cancels. These numbers come from the coefficients. C2H2 has a 2 in front of it, so 2 moles of C2H2 react with 5 moles of O2, so it's a 2 to 5 ratio. Moles of O2 cancel. All of your units should cancel except for the unit that's asked for in the problem. Then you just do the math. 7.42 times 2 divided by 5. And that answer will be in moles C2H2. 6.168 moles of C2H2. Moving on, the mole ratio, this step right here is the mole ratio, and the mole ratio is included in every stoichiometry problem. It's the simplest kind of problem when you're given moles and asked to find moles, but unfortunately in lab we don't really measure out moles. Instead we measure out grams. So we'll need to know how many grams to start with in order to end up with the desired number of grams in our product. Those kind of problems are called mass-to-mass problems, which brings us to target 9.2. If given the mass amount of one of the reactants or products, I can determine the mass amount of all of the other products and reactants. So this is a mass-to-mass problem. Steps for this: just write and balance the equation. Sometimes you have to do that, sometimes it's given to you. Once you've written and balanced the equation, change your given to moles. If you're not given moles, you're always going to change it to moles first. Once you've changed it to moles, you can do a mole ratio, as we just did on the previous two problems. The mole ratio changes you from your given to what's asked for. And then once you're in units of what's asked for, convert back to unit desired, unit asked for. So we will start with mass-to-mass problems, gram to gram. First example, 6.50 grams of aluminum react with an excess of oxygen. That just means you have more than enough oxygen to react with all of your aluminum. How many grams of aluminum oxide are formed? So that says that we have 6.5 grams of aluminum, so I'll write it right here. And it wants to know how many grams of aluminum oxide. So this is where we're going, X grams. So the first step is to write down our given, which is 6.5 grams of aluminum. The step said to change to moles, so I need to change this to moles of aluminum so that I can do a mole ratio, because I know that for every 2 moles of aluminum oxide that are made, 4 moles of aluminum are used. So I can't use that yet because I'm in grams and these numbers relate moles. So we'll change it to moles first. And I know that in 1 mole of aluminum, if I look at the periodic table, it contains 27 approximately grams of aluminum. This number comes from the periodic table. This is the molar mass. I can cancel out my grams. Now I'm in moles of aluminum. Now it's time for the mole ratio. I'm asked for moles of aluminum oxide, so that goes on top. And I want to cancel out my moles of aluminum because that's what's here. These numbers come from our coefficients we use to balance the equation with. So there are 2 moles of aluminum oxide that are formed for every 4 moles of aluminum that react, a 2-to-4 ratio. Cancel out your moles of aluminum. At this point, if you ended the problem, your answer would be in moles of aluminum oxide. If they ask us for moles of aluminum oxide, we could stop here. But they ask us for grams of aluminum oxide. So we have one more step to go. We need to change moles of aluminum oxide to grams of aluminum oxide. So we want to put grams of aluminum oxide on top. Oops. And we want to put 1 mole of aluminum oxide. We need to calculate the molar mass. We need to know how many grams are contained in 1 mole of aluminum oxide, and we get that from the periodic table. The molar mass of aluminum oxide is roughly 102 grams. I got that by multiplying 2 times 27, which is aluminum's molar mass, plus 3 times 16, which is oxygen's molar mass. Now, cancel out my units, moles of aluminum oxide, moles of aluminum oxide. The only unit that I'm left with is grams of aluminum oxide, and that is what's asked for in the problem, so I know that I'm finished. Next, I just do the math. 6.5, let's do this really quickly. 6.5 times 2 times 102 divided by 27 equals, divided by 4 equals. My answer is 12.27. and that is grams of aluminum oxide. And that is a mass-to-mass problem. We'll do one more of those. Alright, here's one. Calculate the number of grams of ammonia produced when 5.4 grams hydrogen react with excess nitrogen. This involves all the steps. It doesn't give me the balanced chemical reaction. I have to write the reaction and then I have to balance it. So it says calculate the number of grams of ammonia produced. That tells me that ammonia is a product, so I know that it goes on this side. When 5.4 grams of hydrogen, I know that hydrogen is a reactant and it's diatomic, so I'll put a subscript of 2, with excess nitrogen. Nitrogen is also diatomic. Now that I have the equation written, I just need to balance it. Since I have 3 hydrogens and 2 hydrogens, I can make 6 on both sides. Put a 3 here, put a 2 there, and that balances my nitrogen, so it's balanced. Now that I have my balanced equation, I'll go back and look at the numbers given in the problem. 5.4 grams of hydrogen, so I know that I have 5.4 grams of hydrogen. I have more than enough nitrogen to react with all of my hydrogen, and it says calculate the number of grams of ammonia. So I want X grams of NH3. I'm starting with hydrogen and going to ammonia. So I'll write down my given, 5.4 grams of hydrogen. And first step is, if you're not given moles, always change to moles. So to change to moles, I want to know the grams of hydrogen that are contained in 1 mole of hydrogen. So this is the molar mass of H2. There are 2 hydrogens and each one has a mass of 1 roughly, so 2 times 1 is 2. These are equal. 1 mole of hydrogen contains 2 grams. Go ahead and cancel your grams. Now it's time for the mole ratio. I'll put moles of what's asked for on top, and they're asking me for ammonia. And I put moles of what's given, which is H2, on bottom. These numbers come from the balanced equation, the coefficients. There's a 2 in front of NH3, so I'll put a 2 there. There is a 3 in front of H2. So cancel your units. Moles of hydrogen, cancel with moles of hydrogen. The last step, because they asked me for the number of grams of ammonia, I'm in moles of ammonia. So I want to change it to grams of ammonia. And since I have moles of ammonia, it's 1 mole. 1 mole of ammonia contains 17 grams of ammonia. I got this number from the molar mass of NH3. 1 nitrogen is 14. 3 hydrogens times 1 is 3, so 14 plus 3 is 17. Cancel moles of NH3. Check to see that all units are canceled except what's asked for. 5.4, or they're asking us for the number of grams of ammonia, and that's where we're at. So now we just do the math. To do that, I would say, let me get my calculator, 5.4 times 2 times 17 equals divided by 2 equals divided by 3 equals. And the answer is 30.6 grams. If I start with 5.4 grams of hydrogen, I will end up with 30.6 grams of ammonia.